This is an automatic load separation panel. So looking at it very well, you see that we are using 4 contactors for this and 2 8-pin relays. This pin relay, this is pin relay and this is pin relay. You can decide to use 8 pin, you can decide to use 11 pin or maybe 16 pin, but make sure that you use the terminals as indicated. So looking at the whole thing, you see that we have the contactor 1, which is K1, used for utility. Utility in Nigeria could be is PSE, and that is NEPA. Okay, so K2 is generator, which is contactor 2. We use contactor 2 for generator. Then the contactor 3, we use it for the mediator contactor, or you call it interlock contactor. Then the contactor 4, we use it for the inverter. So this is load separation panel in the sense that when there is utility supply, it's going to supply both the general load and the separated load. When there is generator supply, it's going to supply both the general load and the separated load. But when you are using only inverter, only the separated load will be powered, the general load will not be powered. So let's go ahead and design this panel using the components. So looking at this on this table, you see that we have arranged the components. We are using 4 contactors, which is 1, 2, 3, 4 contactors, and the 8-pin relay. This is 8-pin relay, and we are using this timer in case you want to delay something. But if you want this timer to work like pin relay, just set it as 0 and it will function exactly like pin relay. Now we are using this as the load, both the general load and the separated load. So let's start the connection. Alright, so looking at the diagram, you see that we have to connect using this diagram. Looking at the diagram, you see that the live wire, I'm starting from this utility supply. The live wire from the source connects to L1 of the contactor 1. I'm using this one, contactor 1, and connects to where 2 of the pin relay. This is the pin relay 1, 8-pin relay, and from 2 connects to 1 of the pin relay. So I'm using this as the supply 1, which is the utility supply. So I'm going to connect it to where? L1, and this is L1 of this contactor here, and from L1 also there is a wire from L1 going to 2, so I'm going to connect this together with this one that is going to 2, just like this. Alright, so from this L1 goes to 2 of the pin relay. So this is 2 of this pin relay. I'm using 8-pin relay. It depends on the pin relay you're using. You can use 11 pin, but make sure that you connect according to the instruction I gave. The normally close to normally close, normally open to normally open. So 2 and 7 of this pin relay are point terminals of the pin relay. So I'm connecting to 2, and from the diagram you see that 2 connects to 1. So I'm connecting this 2 to terminal number 1 of the pin relay. So this is the terminal number 1 of this 8-pin relay. So looking at the diagram very well, you see that terminal number 3 of this pin relay connects to A1 of the contactor. So let's go ahead and connect it. Okay, so we connect the terminal number 3 of this pin relay to terminal number A1 of the contactor. This is terminal number A1 of this contactor 1, which is the NEPA contactor. The utility contactor is the NEPA contactor. So looking at the diagram very well again, you see that we have connected this. Now let's face the neutral aspect of it. Looking at the diagram, you see that the neutral supply connects to L2 of the contactor. The same neutral supply connects to A2 of the contactor. The same neutral supply connects to 7 of the pin relay. So let's connect it. We are linking L2, A2, and 7 together. So let's do it. Alright, so from this L2 to terminal number A2 of the contactor, this is A2 of the contactor, and from terminal number A2 of the contactor we connect to terminal number 7 of the pin relay. So this is the terminal number 7 of this pin relay here, so we have to connect to this place. Alright, so looking at the diagram again, you see that we have connected the utility side. Let's connect the generator side. Looking at the generator side, you see that the supply of the generator goes to L1 and L2 of the contactor 2. So this is the supply of the generator, and this is the contactor 2. So I'm connecting to L1 and L2 of the contactor 2. So then looking at the diagram again, you see that the L1 connects to where? 8 of the 8-pin relay. Then from 5 connects to A1, so let's connect L1 to 8. So from L1 of this contactor to terminal number 8 of the pin relay, remember that you are still on the first pin relay, that's pin relay 1. So looking at the whole diagram again, you see that terminal number 5 of the pin relay connects to A1 of the contactor. So we connect this terminal number 5, this is the terminal number 5 of this 8-pin relay here. Okay, so terminal number 5 of this 8-pin relay connects to A1 of the contactor 2. This is the A1 of the contactor 2. Okay, so looking at the diagram again, you see that we have connected this, alright? So you see that T1 of contactor 1 connects to T1 of contactor 2. But before we go then, we have to connect the neutral part. Okay, neutral supply of the generator connects to L2 as well as connect to A2 of the contactor 2. So let's do it. So we have connected the neutral supply of the generator to L2 and A2 as indicated on the diagram. So looking at the diagram, you see that T1 of contactor 1 connects to T1 of contactor 2 and T2 of contactor 1 connects to T2 of contactor 2. So let's go ahead and do it. Looking at it, you see that we have connected the T1 to T1, T2 to T2 according to the diagram. Looking at the diagram now, you see that from T1 and T2 of the two contactors, you see that that's where the general load comes from. So we have to connect the general load. I'm using this as the general load, so I have to connect it to T1 and T2 of any of the contactors. So I'm going to connect it to this place, T1 and T2 of this contactor. So after connecting it to T1 and T2 of this contactor now, you see that another thing is that the T1 and T2 of these two contactors, you can take it from anyone, goes to where L1 and L2 of contactor 3. So I'm using this as contactor 3. So I'm connecting T1 and T2 of this contactor to contactor 3. So L1 connect, when you look again, you see that we have connected this T1 and T2 to L1 and L2 of the third contactor, which is this contactor 3 here. So looking at it, you see that L1 of this contactor 3 connects to where? 2 of the pin, second pin relay. This is the pin relay 2. This is the pin relay 2 is the 8-pin relay. So we see that L1 connects to 2 from 2 to 1. So let's connect L1 to this. So we have to connect this L1 now to terminal number 2 of the 8-pin relay. So let's connect it. So from the L1 of the third contactor to number 2 of the second pin relay, that's pin relay 2. Then from number 2 of the pin relay 2 connect to terminal number 1 of the same pin relay 2. So we are connecting to terminal number 1. So looking at the diagram now, you see that the L2 of the contactor 3 also connect to A2 of this contactor, the coil of the contactor 3, that's the K3, coil of K3. L2 connects to A2, from A2 connects to 7 of the pin relay 2. So let's connect it. So we connect the L2 of this contactor 3 to terminal number 7 of the pin relay, as well as the terminal number A2 of the contactor 3, which is this. So looking at the diagram now, you see that we have to connect the terminal number 3 of this pin relay 2 to A1 of contactor 3. So let's connect it. So we have connected the terminal number 3 of this pin relay 2 to terminal number A1 of the contactor 3 as indicated on the diagram. So looking at the diagram, you see that we have connected everything here, remaining this side. So looking at the diagram, you see that the inverter supply connects to L1 and L2 of contactor 4. So I'm using this as contactor 4. So I'm going to connect inverter supply to L1 and L2 of the contactor 4. So I'm using this as the supply of the inverter. So this is L1. Looking at the diagram, you see that it connects to L1. From L1, you see that it connects to where the 8 of the pin relay, which is pin relay 2. So I'm connecting this L1 now. This is L1 of this contactor here, and I'm connecting it to pin relay, which is terminal number 8. So looking at this, see that this is the terminal number 8 of the pin relay. So L1 and 8 of the pin relay are connected together. So looking at the diagram again, you see that terminal number 5 of the 8 pin relay, which is the pin relay 2, connects to A1 of this contactor 4, which is K4. So I'm connecting terminal number 5 of the 8 pin relay, which is this, to A1 of this. So let's connect it together. So we connect this terminal number 5 to terminal number A1 of this contactor, which is this. So we are connecting it to terminal number A1. Alright, so we have connected this to A1. So looking at the diagram, you see that the neutral supply of this inverter goes to where L2, and from L2 it goes to A2 of the contactor 4. So this is the neutral supply of this inverter, this blue wire. So I'm connecting it to where the A2, and from A2 it goes to terminal number L2. Sorry, it goes to terminal number A2. So this terminal number L2 of this contactor, and from terminal number L2 of this contactor it goes to terminal number A2 of the contactor, which is this terminal number A2 of the contactor. So looking at the diagram again, you see that terminal number T1 connects to T1 of K3 connects to T1 of K4, and T2 of K3 connects to T2 of K4. So let's connect it. So looking at, you see that T1 of this contactor 3, sorry, connect to T1 of contactor 4, and T2 of contactor 3 connect to T3 of contactor 4. So looking at the diagram now, you see that the load, that is the separated load, is connected to T1 and T2 of the two contactors. So you have to connect the separated load to T1 and T2 of contactor 3 and contactor 4. Alright, so looking at this, see that we have connected T1 and T2 of contactor 3 to T1 and T2 of contactor 4, and that's where the load, that's the separated load is. So I'm using this as a separated load. I'm using this one as the general load. Alright, so let's go ahead and fix the pin relay. Okay, so I will put this pin relay, and this timer I will set it as 0 so that I can work as pin relay. So if I want you to delay before switching, I can set it to any time, but I will set it to 0 so that I can work as pin relay. So I will insert it here. So now we have to test. Remember that we have three supplies: the utility, which is this one, this is the utility supply, which is this on the diagram; the generator supply, which is this, and which is this on the diagram; and then the inverter supply, which is this I'm holding, and which is this on the diagram. So let's go ahead and do the testing. Alright, so I've arranged the power supply for this, and these are the three supplies. This is the inverter supply, which we know, generator supply, and the utility supply, which is NEPA or PSTN in Nigeria, utility supply. So what we have to do is to test. You see that when inverter is on, it will only power the separated load, because according to the diagram, you see that inverter can only power the separated load. But when NEPA, that is utility supply, and generator is on, it will, all of them, it will power both the separated load and the general load. So let's see it. So looking at it, you see that when the inverter is on, it will power only this one, which is the separated load. This one is not on, meaning that there is no supply at the general load. It only powers the separated load. But when you are using generator will automatically switch both the general load and the separated load, just like this. You see that the separated load and the general load is on for generator. So even if you remove this one, nothing happened. Because why? Because there's no supply at the inverter side. Okay, so looking at it very well, you see that when utility comes, utility have to take over from generator and supply both the separated load and the general load, just like this. You see that it has supplied both the separated load and the general load, and there's no supply at the generator side, showing that the separated load and the general load are now on, because the utility is powering both of them. So if it is now, if the utility goes, it will return to generator, just like this. And when there is no generator, it will return to the inverter, just like this. And when there is no inverter, the whole supply will go. You see that the inverter will only supply